is more difficult in statistic, data collection, calculation, or analysis?
That's a good question actually. I feel data collection is most important thing. Why? Because we are using many things, many scales. The pictograph or the trend analysis is not suitable for all the data. We have to choose the data analysis tool which is suitable for the particular thing. Mathematics and statistics, so you can say, is the only science which is human made. Good evening, one and all. So today's session, we basically discuss about uh, quantitative analysis. See, before conducted exam, you have student scores. Then what you can do with that scores, how you can interpret, what are the statistics that you can apply. So basically, we will be discussing about this basic phenomena. So before we start with the statistical part, which is most of you might feel little boring as well. We will do some one activity. So what you have to do is I'm asking you a couple of simple questions. The first question is why do we do an assessment? So you can see the QR code on your screen. From your mobile camera, you can scan that QR code. It will navigate to a website, and in that website, you can see this question, and you have to just respond to that question. So now these answers are popping up. To know the improvement, to check understanding, to measure, to test knowledge. Correct. Very good. To test knowledge, many of you are those who have voted or given response by the time they're believing testing is knowledge is the prime measure the learning progress to know the improvement. Very good. Very good. The check the transformation. Very good. To check the understanding, to test the knowledge, to check the understanding, it is the same. To know the improvement, understand, check the learning outcomes. Okay. The check the achievement of students. Okay. 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 So many of you are believing that assessment we do to check learning outcomes and to test the knowledge or understanding or the skills that student has earned. Okay. Very good. Very good. So good. You all are doing well. So I mean, you're having and will understanding why we do an assessment. Now I'm moving to the next question. Uh, on your screen, no need to again scan it. There is option next question. You can move to the next question and you can respond. The question is how we do assessment. What tool we use to do an assessment. Okay, you can give a test. Correct. We conduct exams, quiz, psychometric test. Okay. You can ask them to do a presentation. Very good. Exams, give a test. Oral or written exam. Okay, very good. Exams or observation also activities. You can give them activities and you can do the assessment as well. Quiz. Okay. Very good. Very good. Quiz projects. Okay, you can give projects also. Correct. Many of your believing quizzes, activities, and projects are the tools. Okay, very good. Okay. Either you give any kind of this tool, maybe oral exam, oral test, written exam, activities, projects, unit test, whatever you are giving, students are answering those, and there are two types of responses we are getting, or two types of data we are getting. One is a quantitative data and another one is a qualitative data. Quantitative data means what? If we get the students' response and we can able to measure it in terms of numbers, then we can call it as a quantitative data. For example, you ask a multiple choice question, there is one correct answer. If they are giving, you can say, whereas, if the correct answer is given, you can quantify it for mark 1 or marks 2 or something. If you have asked their views or opinion or their maybe an essay, you ask them to write an essay, and then the responses that you got is a qualitative response, and whatever analysis we are doing is a qualitative analysis. But in our school setup, we even the response is a qualitative one. We quantify it by having a model answer key, or we can say marking scheme. We use these two tools to quantify the qualitative remarks as well. So ultimately, we are getting quantity or numbers as in terms of measurement of students' performance. Very good. Now let's move to the third question. Okay, you like we got a number, or we got the numerical data. Well, what you do with that numerical data? How like if you want to analyze the data, why we do analyze? If we don't do that analysis, if whatever performance students has performed, you measured it and it is communicated to the said student, that's it. Why we should go ahead and do the analysis of the result, or that particular student's performance? So the responses are coming to improve, to give a feedback, to check awareness, basically pointless. Okay. To improve teaching method. Okay, yes, it is a feedback to the student teacher as well. Okay, to improve. So basically to improve the system. So right from the policy making, compare with others. Yes, comparative analysis if you want to do, to compare with one student's progress with the other student progress, or one particular group of students, maybe division A's performance with the division B. Correct? So I'm happy that most of you are, whoever has given responses, they're believing to improve. We have to we have to do an analysis. Very well said. Uh, whatever numbers you are getting, that if you do the analysis, it will improve entire ecosystem, right from the students, right to the teachers, to the administrators, and entire education system can be improved. But yes, being as a teacher, we are delimited with maybe few particular classes. We will be teaching to the few particular couple of subjects to that few particular classes. And then also in our own capacity, we can do the analysis to improve the ecosystem. Okay, I'm stopping the presentation, this thing, and we will resume back to our presentation. So, like we all agree, to improve the entire education system, right from the student to the administrators, we need to do the analysis of the student scores. So these are the few basic statistics that you can apply. The first three, that is mean, median, and mode, are called as measures of central tendency. What does it mean? See, if in your class there are 100 students, and if you have conducted an exam, so you got an 100 scores, then to find out if you apply these parameters like mean, mode, median, the value that we are getting is moving towards the center of that data. So like for example, mean, which is called as average. So if you want to find an average performance of the class, the value as in mean, what you are getting, it is very close to the center point of the given data, and therefore it is called as central tendency. The parameters, the value that you are calculating on these three parameters has a tendency to move or to go to closer to the center of or center point of given data. Whereas range, or maybe deviation, or we can say quartile, standard deviation, quartile deviation, these two, three statistical parameters speak about how the data is spreaded alongside the center. Alongside center, what are the values at the center? At the center, we are having mean, mode, median, and how the data is scattered around the mean, mode, median, or around the mean, the scatterness that we can find by using standard deviation or quartile deviation or range. Whereas the last two, that is percentage or past percentage, these are the fundamental basic statistics that we all are doing. That means if you conduct an exam, then based on the student's performance, you can convert it into the percentage. So that is the basic thing that we are doing. That is the called as standard comparison tool. But we will go beyond that, beyond percentage. We will discuss about mean, median, mode, and other parameters of variance. So I'll just discuss about this. What is mean? It is an average. Average of given scores. So what is the formula to find? You have to add the total scores, and then you have to divide the number of scores. Like for example, there are 30 students, and there was been test is conducted. If you add the score or marks achieved by these 30 students, the sum here it is coming 580. Then simply the total marks is divided by 30. We can find the average, or we can find the mean. So that is again the central value of the given data. So what this 18 says, if we are getting high, see this 18 is mean, means it is marks. Suppose that exam is out of, say for example, 20, and you got 20 out of mean, you got 18. That means the class is performing well, or the class performance is high. If this exam is out of say 100 or maybe 50, and out of 50 the mean is coming 18, the test was out of 50 and the mean of the entire class is coming 18, that means the performance of the class is low. So this numbers also we can interpret. So this is one example given. Suppose these are the marks obtained by 10 students. So simply you have to add these marks. So like this 5 plus 8 plus 4 plus 10, you have to add all these marks. It will come into the numerator. And then how many students are there? 1, 2, 3, so dot 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 10 students are, you simply divide by 10 and you will get the marks 7. So now this test is out of 10 and you got 7, then you can interpret as the performance of the class is above average, or above the mid, or we can say the class is performing moderately well. There are some merits, like finding mean is very simple. It is very easy to understand and calculate. It is based on all the values in the data. So if whatever students are present, whatever marks they are got, every score is contributing to calculating the mean. It has some demerits. you cannot calculate mean if some values are missing. Like for example, one student has answered attempted the exam, but he did not answer the question. He simply sat and he had some emergency and leave. So in attendance, you are counting that students, but he has not responded the answer. If his marks are missing, then it will affect the mean, and the mean will not be correct. It affects the extreme values. Like for example, there are some students who has performed either at higher range or at the low range, which is not in that particular overall class performance. Then the mean value will be affected. Okay. The second parameter is median. Median is a simply middle value in the given data. So the data, it is a midpoint which is dividing the data in two parts. So what we have to do? We have to simply arrange the data in ascending order, and then you have to see if the numbers are odd or even. Whichever the number which is coming at the middle will be the median. So median is a simple middle value or middle number which when the number is arranged in ascending or descending order. Where it is useful if the students scores are high or low. See why we use median instead of mean in that case. If there are some students who has extremely scored high, that means they are affecting mean. So like for example, many students has scored marks between 8 to 12, but there are only two students who has scored 25 out of 25, and therefore the mean will change. And therefore we also consider the median when the class performance is uneven or there are extreme performer in the class. So there are two conditions if the number of students are odd or the number of students are even. If number of students are odd, then there is no problem. Like for example, in the first case, here you can see number of students are odd. That is five students are there. So 1, 2, 3, 4, and 5. So five students are there. So this is odd number. You have to simply arrange the score in ascending or descending order first. Now here in this case, ascending order we have arranged. So since it is odd, we can find the third student is the middle value. There are two to the left, two students to the left, and two students to the right. So third is the midpoint, and then we can say 6, the third student score, whatever is the median. But what if the numbers are even? So like there are 6 students, like 1, 2, 3, 4, 5, 6. Then again, the first step is same, arrange it in descending or ascending order. Now you can see the third and fourth, these are the two students coming at the middle. Because if you consider these two, then there are two to the left, two scores to the right. So 4 and 6 is there. In that case, we can find mean of these scores of these two students. How we can find mean? The addition of these two divided by 2. So this will be 4 plus 6 is 10, divided by 2 is 5. So we can say median is 5. So if it is odd, then finding median is easy. You have to simply find the middle point. If it is even, then we have to consider both the scores. So it has easy to understand. It has merits. It is very easy to understand, very easy to calculate. It does not affected by extreme values. Extreme values, it may be simply we are we are finding the midpoint. It is not based on the values itself. It is just a middle point. For larger data set, it is difficult to arrange in ascending or descending order, and it cannot be further. Mean can be calculated further. You can use mean to calculate standard deviation or to do inferential statistics. But median cannot be, it is difficult to use median for further calculations. So last one is mode. Mode is nothing but the most frequent data value. Like for example, in a given data set, like for this data set, if you see there, this 5 number is repeated 3 times. So we can say 5 is the mode of. So the mode is the number where students has got that marks. Simple. So how many modes a particular data may be having? It may be having multi modes. Like for example, in suppose this in this data there is one more student has scored 10 mark. So you can find 5 is repeated 3 times, 10 is repeated 3 times. So in this case, this data is bimodal and it has two modes, 5 and 10. Same case, it may be three. Suppose, for example, one more student got 8 mark. Then there are three things, three numbers which is having thing. So this is trimodal and modes are nothing but 5, 8 and 10. Why this used to just find out what is the how the students which mark or what is the score which is maximum students are getting. So basically these three mean, mode, median are measures of central tendency. It gives some values which is tending to the center, and it has some interpretation also. Let us move to the next, that is variation. That is how the data is scattered alongside the mean. So basic fundamental calculation is range. It is very simple. You have to find out the lowest score of in your scorer in the class and the highest scorer in the class, and you have to find the difference between these two. So range is the simple and most general measure of variability. So we can find the data is scattered from in this range. Like for example, this is the data. These are the again few students has answered the question this exam, and you found you have to find the smallest number, and you can see the 4 is the smallest number. You have to find the highest number, that is 15. So lowest, smallest score, lowest score is 4, highest score is 15, and you can just subtract it and you will get range. That means so data is scattered in 11 marks. So this is simple again. It's easy to calculate. When data is too scattered to justify computation of computation, it is more major or precise variability. Why it is important? Like for example, there is the division A, division B, and if division A's range is say 5, that means they are out of the question paper is out of 20 mark. The lowest scorer is say 15 and highest scorer is 20. Then obviously the range is 5. Again, there is division B. Again, 20 mark test is conducted. The lowest scorer is 10 and highest scorer is, say, for example, 20. Then you can see the range is nothing but 10. So you can say this class division A is having, say, unanimous, or so we can say the performance is good because all students has achievement is quite high. But this class, there are some students who has scored less. So, I mean, to do these comparisons also, we can use the range. So this is just the initial basic statistics. It helps us to make, there are some demerits. Like, for example, it's just a rough comparison. You cannot interpret high statistics on this or a high thing. It is just an interpretation. Like, for example, if there are extreme values, then it will affect the range. So therefore, it has a demerit that it will not help us to do further calculations and all. Mm. Next one is quartile deviation. Again, it is the same part. It is same extension part of the median. Uh, like in median, what you are doing in median, the entire data, entire scores is divided in two parts. Now in quartile, we are increasing the number of parts. Like usually in quartile division, it is divided into 4 parts. In median, it is 2 parts, and in quartile division, it is 4 parts. In deciles, it may be 10 points, and in percentiles, like we find percentage, what we are doing, we are dividing into 100 parts, and we are finding the percentiles. So percentile is again, we can say it is the extreme part of the deviation. In other sense, in rough sense, we can say it. Okay, so. Now, so what we are doing, we are finding the median value of the given data in at 4 parts. So there are three, since we are dividing into 4 parts, there will be 3 quartiles. So the first quartile is called as lower quartile. So it is the median of lower half of the data set. That is, it measures 25% of the 25% of the data lies below the Q2 point. Second quartile is Q2, which is also median value. It says 50% of data lies below or above the Q2 point. And third one is Q3, that it says 75% data lies below the Q3 point and 25% above. So suppose your students, so what we are doing, we are arranging the data in ascending order, and then you are finding these 5 points itself. Okay, we'll take an example to understand it. Like for example, this is the data. What we are doing, this is scores achieved by the students, we can say, or it is just simply data. What we did, we arranged in uh, ascending order. So smallest comes first and largest at last. And now we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are there. So it is odd number. So if it is odd number, we can find Q2 first. So odd number means you have to find number where equal number of student scores to the left and right. So simply say sixth will be the sixth term will be the odd number where 5 will be to the left or 5 to the right, and 1, 2, 3, 4, 5. So this will be the sixth. 5 are here, 5 are there. So we can call it as a Q2. Now again to the left we are having 5. To the right again we are having 5. So again, if you consider this left data as a one data set, then the third will become Q1, and similarly, this will become Q3. Ninth will become Q3. So Q1 is 15, Q2 is 41, and Q3 is 43. So simply it is the midpoint, middle point, not midpoint, middle point, which dividing the scores. So and how to find the deviation? So simply you can use Q3 minus Q1 upon 2 to find the quartile deviation. So based on that, Q3 is 43 minus 41 divided by 2. It gives 2 upon 2. So it is 1. So deviation is 1 for this data. Okay, so this is again illustrated the same way. The data is arranged this. So Q1, Q2, Q3 we found. Next one is standard deviation. This is what we say most famous measure of depression or variability. It is most stable index also. It is denoted by symbol SD or Greek letter sigma. It can be calculated on the two things. It is square root of variance actually. So, and in this case, if the data is ungrouped means what? The students are there. Suppose there are 5 students and these are their scores. 5 students scores are this. Then what you have to do? You have to find the mean of this. How we can find mean? You have to add this 6 plus 8 plus 10 plus. So the summation is 15. 5 numbers are there. So 50 divided by 5. So mean is 10. So once you find the mean, then you have to simply subtract that mean from each value. So 6 minus 10, 8 minus 10, 10 minus 10, 12 minus 10, 14 minus 10, and you are getting these values. That is deviation. And simply you have to square it. And it will give you x square. And if you add, it will give a summation of x square. So summation of x square divided by n is 50. If you put and if you take it square it, you will find the standard deviation. It's simple. Same thing is solved here. So 10 and this is 2.83. That means the deviation of the data from its central or from its mean is 2.83. And you can use mean and deviation to find students' performance. Like one particular student's mean or average performance of class is say 10 mark, and one particular student has got 12 marks. Then you can say so it is in the second half, that is 10 plus 2 is 12. So that way you can find. We'll see how this you just understand this, how to use the statistics, we'll see later. Um, if the data is ungrouped, means if it is the students, number of students are more, like then what you can do, you can just find like how many students has scored between 10 to 15, how many students has scored between 15 to 20, that you have to count. Suppose there are 3 students scored between this range, the 5 students scored in between this range, 9 students scored between this range. So that is called as frequency distribution table. And based on that, you have to find the assumed mean in this case. So here the highest frequency will be your assumed mean. This is assumed mean because finding mean is not possible, or you can use assumed mean method here. So you have assumed that this 18 is assumed mean. So simply they have to subtract the 18. So like this, no, assumed mean you have to score it 0, and then to the downwards you can write it -1, -2, and so on. To upwards you can write plus, and simply you can take it square, and then you do the calculations. I'm not going in detail with this thing, but it is very simple. One simple formula is there, and by using that formula you can uh, find it. So like this formula is summation. I is nothing but a class interval, that is upper limit minus lower class limit of that particular class. So here this 10 to 15 is a class, 15 to 20 is a class. Okay. So square root of summation of f dash square upon n. So f is the frequency, this frequency we got, and x dash is the variation, and it's square. We are just making the square and doing it. So here we got the SDS. Okay. So this numerical, I'm not going in detail much about it, but yes, you can find the standard deviation based on that. It is rigidly defined. It has always definite value. It is based on the observation data. Every observation is affect the standard deviation, is let affected by fluctuation in the sampling or fluctuation in the data. It is difficult to understand and interpret. Difficult means some calculations are involved. Basically, mean you have to calculate first, and it is built up on the mean. It gives more weight to the extreme value items than less to those which are nearer to mean, because we are finding the difference. We are finding the variance. So extreme data is compared. Okay, so these are the statistics. Based on these statistics, what analysis we can do? The first analysis that we can do is comparative analysis. Like for example, if you want to compare performances of two groups to identify trend differences or areas requiring improvement, we can do comparative analysis. What are the situation where we can do comparative analysis? Like example, you want to compare two classes like standard A and standard 8A, division A and division B, or you want to compare same class but for two subjects, or same subject same class for two different exam, maybe formative unit test and maybe term and exam, or term and first term and second term, or maybe you can compare with it. So basically if you want to compare two things, you can do it. What is purpose to do such assessment? To identify which class, which group is performing better, which group is having is underperforming, to detect. And suppose there are two classes and you taught one class by one particular method and another class by some other method. So based on this analysis, you can uh, get a feedback about your teaching, like which method was appropriate. That based on the performance, you can calculate that. You Based on that, you can recognize the best practices as well, and it is highlight the subject and class. How we can do it? What statistics we have to use in comparative analysis? We can use mean. We can use mean to compare overall performance of one particular group, and you can compare means of two classes also. We can use median. When we can use median? If the higher the extreme values are there, we can use median, and then you can typically compare the median of two classes, and you can get some pass percentage. The pass percentage means what? Like in one particular class, there are 10 students, and out of that, 5 students are passed. Then 5 divided by 10 into 100, so 50% has passed. So pass percentage of one class compared with the pass percentage of the another class. And similarly, you can calculate the standard deviation, and then you can see how the that scores or students' marks has scattered alongside the mean. Effect size, simply you can find the difference between mean of class A and mean of class B. You find the difference, it will give you the effect size. Like for example, the previous example that we solved, we said mean was say 7, and for another another class, mean was 10, or mean was 5 and 10. And if you subtract 5 and define the difference between these two, then you can say the effect size, the another class effect is more than this. So there is one example given. Suppose 8A, 8B is given, mean is given, pass percent is given, standard deviation given, and you can interpret that class B, where deviation is more, where mean is low, and passing percentage is also low. So there is wide variation, and it shows that many students are struggling. So these are the statistics if you can use if you want to do a comparative analysis. The second type of analysis is a diagnostic analysis. So basically, we are identifying specific strengths and weaknesses of individual students or the class for a particular learning outcome or a particular what we say objective. So exactly it gives answer to a question where the exact learning problem a particular student is facing. So what is the purpose to do diagnostic analysis? Is to detect learning gaps, plan remedial teaching, provide individual feedback, and improve mastery over the content. What statistics we can use in the diagnostic analysis? The first statistics is percentage. That's question wise success. So simply the example is also given. Like for example, question 1, 2, 3 is there. Then this concept is nothing but you can write learning outcome there. So here recall is an objective applying that knowledge is objective or learning outcome, and problem solving is learning outcome for question 1, 2, 3 respectively. And number of students given correct answer is mentioned in the column number 3 here. And based on that, you can interpret the thing also. So second one is skill-wise performance. Instead of writing learning outcomes, you can have the skills, like particularly if your activity is given or some something is given where students are performing, and then you are using an observation schedule. Then in observation schedule, you have the skill performance also. You can quantify, and based on that, which skill is more performed by the students also you can. Error analysis is finding the typical error. Like for example, this question 2, 42, or question 3, problem solving, 28% students only able to solve it. Then you can go through this question number 3 only, and you can identify which is the common error or common mistake that particular student has done. Even you can find the attempt difficulty index. Like for example, there is one question where many of 100% students have solved it, or there is one question that very few students have solved it. So based on that, with which question is difficult, which question was too easy, that also can be compared. Even attempt discriminations also, like we know, good students in the class, and suppose for one particular question, if the students are not answering, so based on that you can basically, I mean, it's not for come entirely thing, but you can find out the distinguish between these two types of students as well, based on the answers given by the questions. Next one is predictive analysis. So basically, this analysis helps us to predict the students' for future performance, and the rationale or the data that we are using is their his or her past performance. Based on their past performance, we can estimate their future performance or their future academic outcome. For that, we are using the predictive analysis. Basically, it is giving the answer to a question: what is likely to happen if the current trend continues? If the same way the students go on performing, how far he will reach, or how which learning outcomes he will achieve. So what is purpose? To identify the risk failure, to forecast the students' performance, to plan early academic intervention. Like based on the trajectory, you can, if you could able to do any intervention. So that is called as prognostic. Prognostically, if you do something, that is also this predictive analysis can be used. So to do the predictive analysis, what statistics we can use? Trend analysis. Now here some analysis which is mentioned that we have not seen. For example, correlation regression. So it is again little higher statistics, but yes, trend analysis is nothing but the we can represent in the pictorial also by drawing a graph where you can on x-axis you can put the say name of the number of exams that a particular students has answered, and y-axis is performance, and you can draw a trend graph as well. You can find the correlation between his attendance and its achievement, or its achievement in one subject with the another subject. So this correlation coefficient is also there. There is Pearson correlation coefficient. Again, it's based on the standard deviation or other basic statistics. You can use that. And regression is again that part. So that can use moving average is nothing but if when there is a time series data means first unit is to last, suppose student is at the end of the year and you're using their scores of last 10 exams. So next year the last 10 exams will be not the same. Last year, the last 10 years exams will not be same. And then when you are calculating average, so last year's moving average, this year's moving average, or maybe first term and exams moving average, second term and exams moving average, and maybe current moving average we can calculate. And moving average is calculated for the last 10 exams only. So that is moving average. So we can by average nothing but mean. Based on that you can find. Even you can find the growth rate by using percentage. Example is given, like based on that you can do the analysis as well. Last analysis tracks the entire group or entire class, a group of students for over period of time. So cohort is nothing but a group which shares the same common points. Like for example, class 6 performance in 2024, and you can track the class 6 performance for say up to 10 standard or 8 standard. So why we do cohort analysis? To measure long-term learning growth, to evaluate effectiveness of teaching programs, to assess curriculum impact, to monitor institutional performance. So for that we can do analysis. And what statistics we can use? You can use mean score for over the years. So mean score of fifth standard, sixth standard, seventh standard, and so on. Progress gain. So you can use percentage to find progress gain. Cohort pass percentage over the time. So passing percentage in fifth standard, in sixth standard, and so on. And you can put a graphical representation as well. So one example is given. Based on that, you can. So have a quick comparison. So these 5 types of analysis we can do by using the basic statistics like mean, mode, median, standard range, quartile deviation, and standard deviation, and correlation. So comparative differentiating, finding different focuses for to compare two groups. Diagnostic focuses to find weakness and strengths of a group or students. Predictive is to guess the future performance, and cohort is progress over the years. So, and the key statistics is given in the last column.
At what level can statistics be introduced to school students?
Statistics to the school students. See, statistics is an apply. It is again a mathematics. It is applied branch of mathematics, we can say. So right from introduction of number statistics begin. So nowadays, the parents are teaching numbers at the age of 6 months and to 1 year as well. So, but yes, sixth, seventh, eighth standard is the most appropriate age where the advanced statistics has been introduced in the curriculum.
Thank you, sir, for that. Which is more difficult in statistic, data collection, calculation, or analysis?
That's a good question, actually. Data, see, uh, I feel data collection is most important thing. Why? Because we are using many things, many scales. Particularly in research, we can say nominal scale, ordinal scale, ratio scale, or interval scale. And what we say, if like data collection defines the nature of data. If the data is parametric, then you can use parametric test, and the analysis will be the parametric or inferential analysis. If the data is non-parametric in nature, then accordingly the statistics will change. Basically, many people will or some the beginners will miscalculate the nature of data, and therefore the entire calculation goes wrong. So the first step is that, which is the basic, that to understand the data, nature of data, and then preparing a appropriate data collection tool. That is the key point. The entire building, the entire analysis is based on this. Yes, ma'am.
Okay, fine. Yes, that was well explained, sir. So, how did the saying "lies, damn lies, and statistics" by Benjamin Disraeli become so popular? Is there any truth in it?
It is true actually. Um, how to explain it? I mean, it's difficult to explain, but see, you take anything. I mean, you take any movement in your life. You do one basic statistics in your life, that is estimation. We estimate the things, and if you go wrong into it, the entire what we say work that you will be doing will go in wrong direction. So statistics is part of life. We cannot move away from it. If you don't have the skills, then that is as desirous, we can say it is not the appropriate thing for you all.
Thank you so much, sir. Sir, in media, parliament, elections, a lot of data is used by people. So, what type of training may be required to understand their significance?
Very good question, actually. See, the most common, you take a newspaper or many reports that government is, or maybe any organization publishing, they are trying to put it in the picture, in pictogram, and in that we use pie graph or trend lines and all. See, the pictograph or the trend analysis is not suitable for all the data. We have to choose the data analysis tool which is suitable for the particular thing. So I feel understanding nature of data and then choosing an appropriate tool is suitable. Like for example, like I have seen an advertisement of food department about the millet. They put a pie graph, and in that pie graph they given the area of sector, that particular area, about a particular geographical area where they are using that particular millet. So basically, and then what we are doing, we are converting that quantity in a sector of 360 degree angle at the center. Okay, but in that data, the basic like for example, out of 10, on 5 are eating jawar. So it is 50%. Ah, then in your paragraph, the 50% is uh, what we say covered. 50% semisphere is covered. But what if the number of sample is more, 100, and in out of 100, it only 10 are eating jawar in their using that millet in their food? Then out of 10, it is 10% only. The 50% can go to the 10%. So that reference line, the sample size should be mentioned, and many are the data that thing is not mentioned. And then we believe that in this particular geographical area, jawar or that millet is eaten by many people, which is not reality in some time as well. So when your government or non-government organizations or anyone who is dealing with the statistics, the you want to include in the reports. So I prefer or I suggest use tabular data, tabular statistics, and then maybe a graphical representation in support with that, because the graphs, no doubt the picture is says 1,000 words, but are the 1,000 words about the real picture, real data? That is the question. So that is, I feel the appropriate to using. You cannot generalize one particular statistical tool for all the data, which is been observed in many reports, that pictorial presentation is only used there. So I feel that is not correct thing.
Okay, thank you so much, sir. So, do you think statistics is a perfect science?
Obviously, it's a perfect science actually. Um, See, mathematics and statistics, so you can say, is the only science which is human made. Numbers, we made numbers one, two, three. And see, in physics, chemistry, biology, there is intervention. It is there in the nature, we intervened. But statistics is a product of human, it's a child of human brain only. Mathematics is a child of human brain only. And it is based on the entire interaction with the nature and science. So yes, statistics is complete, because now, right from your day begin or your birth to your death, everything is covered by the numbers, and statistics is nothing but dealing with numbers.
So, but then why do people argue on it then? Like,
Argument is better for the statistics as well. We will have the probability that how many people feel statistics is not a good subject. So we can do statistics for that also.
sir, how can assessment insights be communicated effectively to parents, like without reducing learning to numbers?
Okay, that is also see. Statistics are the numbers. So based on the numbers, we can interpret. So I feel, being as an educator or a teacher, the interpretation should be communicated with the parents rather than statistics. Like for example, mean performance of a class is 20 and a particular student has got 5 marks. So what is the interpretation from this data? A simple interpretation, we can say that the student has performed very low in that subject, whereas the entire class average performance is say 15 points ahead from him. So one statement we can, that interpretation only should be communicated, can be communicated rather than entire statistics. Because again, if you share the diagrams or statistics or pictograms, it will be not much use. Instead of that, report, interpretation, results should be communicated with the parents. If parents are maybe having knowledge, enough knowledge about statistics, then the statistical part or the score data of that student's performance can be shared with the parent, where parents also can do their analysis at their own end. But for in general parents, the results or interpretation should be shared.
Sir, Nageshwara has asked, how do reporters collect the data before and after election?
Sorry, I did not get the question.
How do reporters collect the data before and after election?
Okay, okay, okay. See, even nowadays, no, I mean, earlier people see they do sampling. So, like for example, in a constituency, there are 100 booths, polling booths. Out of that, they will choose randomly 10% or 5%, even some cases 2% polling booth only, 1%, 2% polling booth only. Out of 100, suppose 10% they have chosen. So then they will choose 10 polling booths. The data collector, the field investigator will remain there at that polling booth. And once a particular person vote and comes after voting, they ask a question to whom you have voted or like what like. And then based on that, they put the tally marks and the data will be collected and it is analyzed. And then based on that, they interpret or they come to the conclusion ki out of say 1,000 voters, data is collected from 100 voters and 100 voters are saying this candidate is having high probability or high chances of winning, and then they apply some statistics like inferential statistics to find out the mean performance or performance of the entire population. So basically, they are doing sampling on randomization, and based on the random data collected from the randomized sample, they are trying to predict the behavior of entire population. And before and after election, before election, they do a survey, like they visit households, and then they ask like to whom you are going to vote. The same procedure is the same, but post vote they choose the polling booths, and pre-election they choose the households.
Thank you so much, sir. Sir, statistics works well in comparing performance of different students. Is it meaningful approach if we consider individual students are unique and incomparable?
Okay, I think this is good question actually. See, first the first question comes, why we do assessment? Why we do assessment is to identify, like many people have said, to perform, to find the performance and all. Okay, how we can judge a particular student's performance, like to find out how much he has achieved under learning outcome and all. So there we need to compare with something. So this something is nothing but the benchmark, the particular class benchmark, we can say. We can compare with that. Then we can compare with the other students also. And I mean, only benchmark comparison is not enough to get a entire picture, because what are the other variables that affecting the teachers teaching, the entire the socioeconomics or the intelligence level of their students, their peer learning, everything is there. And therefore, when we compare one student's performance with respect to other students or group of students, then we will getting the more appropriate, more clearer, and more exact picture. So therefore, comparison is important. Without comparison, we cannot find a particular student's performance. No doubt, we are believing him, his individuality. We are telling him, in comparison with the entire class, you are here. That means you are giving him a next target to move ahead. Or if somebody has done above average, then we are giving a positive reinforcement to him, saying you are doing well as compared with the other class. So basically, it is not comparison in negative sense. It is comparison to identify the learning gaps or the achievement difference, and give a target to the students to perform in comparison with all other students. It's simple.
Thank you so much, sir, for that. Sir, is a high range in test scores in a class a reflection of teacher performance or student competencies?
We cannot say it is either way. It is the overall together thing. See, if you say it is to a higher score is because of the student, his intelligence, his own studies, but that will be injustice with the teacher who has put the efforts in the class. Maybe his parents might be taking homework at home and all. So it is collective efforts. We cannot say it is only because of his intelligence or it is only because of the teacher's teaching. It is a collective effort. We can say student is performing in that ecosystem. Ecosystem is nothing but the school, teacher, non-teaching staff, administration, parents, every stakeholder should be counted into it.